All right, let's go ahead and get started. Welcome everyone to this joint Quality Counts and Kittelson webinar covering the planning level analysis tool developed into DataPoint. We're going to try to keep the presentation content to just under 30 minutes to allow for about 15 minutes of Q&A after the presentation is complete. If you have questions during the presentation, please type them into the chat or the Q&A tab. At the end of the presentation, we'll address those questions in the order in which they were received. We'll try our best to get to all of them. So now I'll pass things off to the team for introductions, starting with Bastian.
Yeah, thank you, Mark, and thank you all for joining this afternoon and this morning. My name is Bastian Scroeder with Kittelson Associates. I'm the Director of Research for Kittelson, based in Wilmington, North Carolina. I also currently serve as the Chair for the TRB Committee on Highway Capacity and Quality of Service, and so really excited to share a little bit today of how some of the HCM planning methods are now going to be part of DataPoint. But before we do that, I'll hand it over to Nagui for a quick intro.
Oops, I was muted. Good afternoon, everyone. I'm Nagui Rouphail. I'm currently a Senior Principal Engineer with Kittelson Associates, formerly a faculty member at North Carolina State University, and a very active member of the Highway Capacity and Quality of Service Committee. Also worked in the past on many of the planning level methods in the Highway Capacity Manual. So I'm excited for the joint work we've done with Quality Counts, and hopefully you will enjoy the presentation. So let me hand it back to Steve.
Hey guys, my name's Stephen Hollenkamp. I'm with Quality Counts. I run sales at DataPoint. I'm not an engineer like Bastian and Nagui. I'm just a guy that likes making cities awesome and data, and yeah, so I'm excited to share with you what we built today with Kittelson. I'm going to start with, before we get into the new thing we've added, I want to tell you what DataPoint is in general. So, big picture, DataPoint does 4 things very well. First, it automatically ingests traffic data from all count equipment. So, short-term duration, turning movement counts, volume processing counts. The equipment used has raw files. DataPoint can read those raw files and stitch that data together. Real-time data that you get out of intersections through video detection or radar detection, DataPoint can pull in that real-time data and display that as well, stitch it together with the rest of your data, permit count stations, that data as well. So whatever data you have, DataPoint can just get it all speaking the same language. That's step 1. 2, DataPoint visualizes all that data in a GIS, charts and graphs, summary tables, etc., all automatically. And then 3, DataPoint does analysis on this data, kind of next level analysis. We connect all this data to roadway characteristics like GIS layers that agencies have, and then we can automatically calculate DC ratios at intersections, level of service. We can let cities and counties know where they've got speeding problems. We can do VMT analysis. We can do a lot of cool stuff once we're connecting traffic data to the underlying GIS roadway characteristics. 4th, the last thing DataPoint does is you can just click a button and you're exporting that data into whatever format you want it in, whether that's a PDF format or an Excel, whether you want to just have it go right into Synchro or Vstro. Okay, so yeah, that was the first thing I wanted to cover. Next, we developed this product over the last year and a half. These HCM tools we built with Kittelson, they're the smart guys, and girls, they're the engineers in the room. They did all the heavy lifting. It was even Kittelson's idea, I think it was Bastian's idea originally to build this tool, and we loved it. So we built it. And so we have the software team that built it, working with the engineers at Kittelson. We have a bunch of agencies using the platform from across the country. I'll name a few. Alexandria, Virginia. I'll show you their DataPoint instance today. That's the one we use for the demo. Idaho Falls, Idaho, West Vancouver, Canada. Let's see, Downey, California. There's a bunch. Lake County, Florida. Washington County, Oregon. Clackamas County, Oregon. Eden Prairie, Minnesota. And there's a bunch of really big agencies that are going through the procurement process to get DataPoint, and that includes the biggest ones are Oakland, California, and San Diego, California, cities of Oakland and San Diego. Okay, so with that, we're going to pass things back to Bastian. He's going to give an overview of all the HCM kind of like engineering background info, and then I'm going to do a demo. All right, Bastian, back to you.
Yeah, thanks, Stephen. So I'm going to keep it at a pretty high level here so that we can get to the demo, but I wanted everybody to be on the same page when we're talking about highway capacity manual planning level methods, what that really means. And so when we talk about the HCM, there's really two documents. So there's the highway capacity manual, which right now is available as the 7th edition, although these particular methods haven't changed much from the previous 6th edition if you're using that one. That's just what the cover of the 7th edition looks like. But there's also a document that came out a few years ago, NCHFP Report 825, which is the Planning and Preliminary Engineering Applications Guide to the Highway Capacity Manual, or the HCM Planning Guide, as we sometimes refer to it. And so what's really important is that this is part of the HCM. It was published as a separate document, but if you go to HCM Volume 4, these planning methods exist. And so there are just different ways to approaching the question of traffic operations and traffic capacity. And so you can take a look at that guide to get more details, but really the idea is that depending on context and application, different levels of analysis might be appropriate, right? So you can start at a very high level analysis if you have a large analysis area, an entire city, an entire county, relatively low level of detail, but broad application. That's where the DataPoint application comes in. And then the idea is that over time, you then zoom into more detailed analysis. You go to a more medium level where you look at a single roadway, a single segment, or you may even go to a very detailed analysis, even go to simulation at some point. So the idea is that this may be a gateway to get some initial volume to capacity screening to then inform the further selection. And so really the focus of DataPoint is on that high level analysis. And it does that with a method that's called the critical lane volume analysis, which has been around for a long time. Some of you may remember Circular 212, which was published, I don't know, in the 80s or even before then. I don't have the exact date. It's been around for a long time. And really the concept is that, when we're looking at capacity, vehicular capacity, at a point, an intersection, that capacity is shared between conflicting movements, right? The different throughs and the left turns and all that. And so whenever you then have concurrent phases, meaning the two opposing throughs or the two lefts that go together, one set of those movements is deemed as critical, meaning it has the higher volume per lane. So each of those critical movements then requires a certain share of the capacity, or you might say the green time per hour. If the intersection was grade separated, each movement has the full hour of capacity, but because it's at grade, that capacity is shared in time. And so we use a signal, the green time, to allocate that. And so really then if we're looking at the total intersection capacity, it's really equal to the number of vehicles per lane that can be processed in that hour, minus the lost time that is incurred when you switch from one set of phases to the next one. So when you go from your throughs to your lefts, from your major street to your minor street, there's some lost time that is incurred from switching, and so you subtract that. But then the idea is that you can sum up all those critical lane volumes, compare that to your planning level intersection capacity to get that volume to capacity ratio. And that's really what we're trying to get across for an entire system. And that's what really the new application is here. So here's, just a quick numerical example. Envision a little, two-phase signal in a small town. You have north-south going first, then east-west. So there's no left turns here, just to keep it simple. You look at the volume on each of the approaches, which, is included in your count information. What's new now is also getting the number of lanes into DataPoint. So 1,000 vehicles over 2 lanes is 500 vehicles per hour per lane. That's higher than 400 vehicles per hour per lane for the southbound approach, 1,200 divided by 3. You do the same thing for the east-west approach, and you sum those two critical lane volumes together. So 500 plus 600 is 1,100. The intersection capacity is 1,600 vehicles per hour per lane. So that's your 1,800 set flow minus some of the lost time. You divide those two numbers, 1,100 by 1,600, 0.69. So that is the volume to capacity ratio. And so you get this intersection capacity rating that's below capacity. So very simple equation. This is not rocket science, but really what's so significant and what got me very excited about this is that you're not doing that for one intersection, and you're not doing it manually, you're doing it for your entire system, and you're doing it in an automated fashion. So the idea is of looking at your entire system and looking at this volume to capacity screening. You can do some simple growth analysis. You know, what happens if you grow by 10%, by 20%? You can get that look at system-wide hotspots. And then really the idea is, you know, this is planning level applications. Maybe you can prioritize locations for further study, right? You can begin to look at, okay, for the AM peak, for the midday, for weekend, for off-peak, where in the system do I have these potential B over C hotspots? You can prioritize locations for further study, and you can also do some spatial scoping of those studies. Like, is it an intersection study? Is it a corridor study? Is it an area-wide study? And you can see all that very quickly, visually, really without doing any additional analysis. The tool is not really a replacement for a detailed, analysis and other tools that can do signal timing and signal optimization and those types of things, but it can really help you get that big picture and help you scope for a planning level application of where to maybe go next. And so that's really all I wanted to share for intro, and so I'll hand it back to Stephen to do a demo.
All right, thank you, Bastian. I'm going to share my screen here. Bastian, let me know when you can see this.
Yeah.
All right.
We're good.
So thank you, Bastian. So this is Alexandria, Virginia. We're seeing a map of Alexandria. You're seeing a bunch of dots on the screen. You're seeing two different color dots, green and blue. I'm going to give you a brief overview of DataPoint before we get into the actual HCM tools. So we have green and blue dots. These green dots store volume, class, and speed data. When you click on a green dot, what pulls up is a summary panel, the info for this location. And this is all done automatically, again, off of the raw files. You click this blue button and you drag and drop your raw files, and DataPoint does the rest. You see an ADT by year chart. If you want to go further, you can click this View All Details button here at the bottom. Here, we can come to track accounts, and we can see the full data. So we can see for all days where we have data at this location, we can click them. Let's say we want to see this data pre-COVID. We can see our volume, class, and speed data separately. For volume data, we see our peak hour or peak hour volume. We see some charts of this data. We see the full data below. Kind of zooming through this here. The class data, we see our pretty charts. We see the full data below. Again, all this is put together automatically. DataPoint just shows you the info you want to see right away for a location. We can see for speed data, we can see the 85th, the modal, the median, and average speed, posted speed. We see some charts of our data here. And then we see the full data below. Okay, so that's what we do with the mid-block data. The coolest thing that I wanted to show you here is we can show you sort of all this data for a whole city or network or jurisdiction in a big Excel report, and then run analysis on all that data. And so you access that up here, you click this button, you click All Station CSV. I already have it pulled up. So I'm just gonna slide this over. This is what that document looks like. So what we're looking at here is all the data in Alexandria from basically the last 10 years. We're seeing all the locations of the data. I know this is probably hard to see on your screen if you don't have your screen maximized, but the speed limits, the ADTs, the year the count was done, your K factor, your D factor. You see that the 85th percentile. And then for Alexandria, you see this formula, it's the 85th percentile minus the speed limit divided by the speed limit. This shows where they have excessive speeding problems. Also, we've got number of lanes that populate, roadway class that populates, and so we can also calculate we can have level of service populate. So they can just upload data, pull up this report, sort by column X and see where they have level of service issues, sort by column U, see where they've got speeding problems, all done automatically. And then the speed limit data, the number of lanes, the roadway class, all that info is in Alexandria's GIS layer. So they already have that. So DataPoint calculates all those metrics automatically. Okay, so that's what we do with mid blocks. Now on to intersections. So the blue dots, that's where intersection data is stored. When you click on a blue dot, you see the summary panel of the most important info you need to see for that location. You see your peak hour, your peak 15, you can toggle through past days, toggle through AM, mid, PM. You see your turning movements, there's your peak hour factor in the middle. You can toggle through and see your truck percentages, your bike volumes, your bike movements. You can scroll down and see the lane geometry. So whenever we bring on a new city or county, the first thing we do is we build out the lane geometries for all the intersections where that agency has data, has intersection data. And so this lane geometry, we built this, and so they all the intersections come built for our customers. And then if the agency makes a change to the intersection, they can edit it. And so all that's done through our lane geometry configurator, we call it. You can access that a few different ways, but one way is you click these three dots and you click edit lane geometry. And so here, a user could adjust the type of control from signal to always stop, two-way stop, etc. A user could, for each approach, select the different lanes, add lanes, and then what those lanes do. Do they turn left or right or go straight? The user also could select whether there's on-street parking from all four directions and select whether the left and right turn lanes are protected or permitted. This is the info that we need to then run our HCM analysis. We have this map over here to the left to help build out lane geometries. You can zoom in, you can in the corner toggle on the Google aerial so that you can just see and kind of eyeball what's going on at this intersection. Okay, so now for this intersection, we've got the traffic data, we've got the lane geometry. Now DataPoint displays that this signal is over capacity as opposed to under capacity or at capacity. And this is for the PM scenario, so we can toggle through and look at midday or the AM data. But for the PM data, we can see we're over capacity with a critical flow ratio of 1.0. And so this is what DataPoint does automatically. Then what the user could do further with our HCM tools is figure out why, or quickly figure out why, and quickly toggle through different iterations of what could be done at this intersection to fix the problem. And so to do that, you scroll down, you go to view all details here at the bottom, and now three tabs pull up. Station details, traffic count, signal planning. The station detail tab, the only important thing to know here is you can access any and all files that are stored at these locations. And that's not just traffic data files, that could be videos and PDFs and Excels. So this file here, that's downloading. This is a PDF done by CNET Engineering in 2017 on this intersection. This is the sort of thing that gets lost in project folders. That gets lost in project folders or emails. This is the sort of thing that's nice to have, though, when you're investigating an intersection 5 years later. Okay, traffic counts. This tab shows all your data in one place. We see all of our charts. We see our traffic counts by approach chart. All this is done automatically by DataPoint. We see our peak hour and peak 15 highlighted here. And again, this data can be exported to go and sync around the distro. Because like Bastian said, DataPoint is more of a planning tool. And then when you want to go in deeper, you export the data into Synco. But a lot of times you don't need to when you're just doing high-level analysis. Okay, so next we're going to go to signal planning. This is really the meat and potatoes of the HCM tool to see where that resides. So what you're seeing here is we're seeing first at the top here our AM data. We're under capacity. Our midday data, we're under capacity, critical flow ratio of 0.3. Our PM data, we are over capacity 1.03. And this is using the most recent AM, mid, and PM data uploaded. Okay, so next we can see our traffic characteristics. This is our volume data. We can see our intersection geometry details. And then we can see how that flows into our critical movement analysis results. Our sum of our critical lane volumes, 1704. We have a 1.03 critical flow ratio, and we are over capacity. So if a user wanted to figure out why we're over capacity here, they could kind of just look at this data. Maybe they can figure it out but you can also toggle on some advanced inputs. That pulls up our adjustment factors. Now we can see our critical lane volumes. And so we can see we've got 2, 307, and 1397. So we could infer 1397 maybe where we want to investigate first. We can come up to that approach. We can look at our southbound left throughs and rights. We have 1,152 southbound throughs. There's only one lane. So maybe that's the problem. And in DataPoint, you could then go a step further and edit and sort of tease out these theories of that you may have what's going on. Do that by clicking the edit button. Now anything in blue can be edited. So we could say, okay, well, what if we add a lane here? Would that fix the problem? And immediately we can see that it does. Now we're under capacity, 0.59 critical flow ratio. We could say, okay, so if we added a lane, we'd be fine based on 2017 data, but that's old data. So maybe by 2022, we think this number has increased quite a bit. And let's think forward a few years. By 2025, maybe we think this number is going to be nearly double. In which case, we'd have 2,100 cars on the southbound through. We could also go through and update or edit or increase these other numbers. But for simplicity, we'll just update that one. In which case, now we would be at near capacity, 0.94 critical flow ratio. And so we can just get a sense of what our options are here. We also could print this in a report. If we want to take this info and send it to a director or a colleague, we can type out a description and say, okay, if we take our 2017 data, apply growth rates, add a lane, we're still going to be near capacity. But that's the sort of thing you can do in a minute or two in DataPoint. You also can check other data. So you could check the last year's data at the PM and see that we're under capacity here. Plus, we're under capacity at the AM and midday data. So maybe we have a data problem. Maybe we collected data at a weird day when there's an event going on. Maybe this data not super repeatable at this location for the PM. But that's the sort of thing you can do in DataPoint at an intersection. And then the last thing I'll show you is we can get a sense of what's going on, not just at one intersection, but like Bastian said, at the network level. And we do that a few different ways. One, we can toggle on a heat map, all of our data at all of our intersections. We access that over here, and we click this capacity button here. And now we're seeing our AM data, midday data, PM data broken out separately. So if we just look at the AM data, we can see all these blue dots, they turn green if they're under capacity, yellow if they're at capacity, red if they're over capacity. We can look at the midday data and the PM data. So we could see in the PM data, we have this major corridor here in Alexandria that looks pretty good. A lot of greens. We have some yellows here, so maybe we need to investigate further this section of this corridor. We can check and compare against the midday data and see a lot of greens. So we're good in midday. We can check our AM data and see, whoa, okay, here we have some more reds. We have some more overcapacity intersections. And so, yeah, we got something going on here. We need to investigate further. And so the benefit of DataPoint is really this high-level analysis using data you have, because you don't always have the money to get up-to-date data every year. And so this is using data from 2018, 2020, 2022, but it takes your most recent data and gives you a sense of where you have problems, where you need to collect more data, where you need to dive in deeper. And then the last way to do system-wide analysis is you can download a signal planning CSV, which puts all the intersection data in one Excel. I already have that open here, so I'll just drag this over. And so now we're seeing for Alexandria, every single intersection ranked by VC ratio. So we can see our top 10 that are over capacity intersections, our next 9 that are near capacity, etc. This is helpful when you're doing prioritization, when you're applying for grant funding, and you want to show not only where you have a problem, but put into context that, listen, this is a big problem. This is our biggest problem intersections for our city. But okay, so that's high level what we do with our HCM tools. And now I'm gonna open things back up to Mark to let us know if anyone's got any questions for me, Nagui, and Bastian.
Hey guys, just two so far. The first one, if you have more than one count available for a location, can you toggle among them in signal planning?
Yes, yes. And so the way that would work is let's pick an intersection where I know we've got multiple days of data. Short answer is yes, though. But when you're doing that signal planning analysis, we can select all the different days and times where we've got data. So right now we're looking at the most recent PM data, June 13th, 2017, but we can check the day before where we also did a count, or the year before where we also did a count. We can check the PM data where we can see there's only 552 southbound throughs. Yeah, we're checking data in the data here. So that answer is yes.
Are you able to store other files like PDF or photos at the individual locations?
Yes, you can. So you access those here at station details. And so here you can upload PDFs and videos, Excels, and you just click them to download. And so this is a PDF, for example, but this can be images and videos and Excel. So cities and counties use this as a way to just store all sorts of assets, digital assets that you'd rather track down and find in a GIS interface rather than just having a million files in folders on your computer. We also have ways to pull out of this capacity part here. We've got these search tools up here, which allow us to find certain types of data. So we can type in anything. We can also look for data we just want to find where we have speed data or where we've got byte count data, or we want to find data from a certain time range. We can do that here. But we can add the functionality to make these tools work with those other files that you might want to store at these locations. So if you're storing all your signal timing plans and you want to quickly see where you have signal timing plans, where you don't, you can do that in DataPoint. So yeah, the answer to the question, yes.
If you have quality count at an intersection, will the intersection automatically appear in DataPoint? If so, what else would you need to manually add in order to get DataPoint to work? Maybe like lane configuration.
So we offer DataPoint whenever we're doing very large count projects. We offer it as a discount. We don't have, if you're an engineering firm, you're doing a traffic impact study and you get one or two counts from us, we don't have that data automatically pushed to DataPoint. So I'd say if you're working with any agencies and you think they might want to have off of those counts automatically the level of service calculated, automatically speed analysis calculated, or automatically VC ratios, we can include that for those big count projects. The count price is a little higher, but we can include that. But for just one-off counts that we provide for you, we don't have it automatically going to DataPoint yet. I'd say that if you're getting enough data done, collected by us, then let us know what you'd like, what would be ideal, and we could maybe find a way to make that work. The only additional step would be talk to me. Reach out to me, reach out to your market manager and say you want to talk to the DataPoint guy, and we can maybe figure something out.
And then the lane configuration aspect.
So every intersection would need a lane configuration built. We build them pretty quickly. And so if we were including that, we'd find a way to price that. It takes a minute or two to build that out. But as you saw with the tool, it's pretty straightforward. We also could provide you the tool so you can build out your own lane diagram. So you could, if you're collecting data and it's from us or not, data could be in DataPoint. You spend a minute, build out that lane diagram, lane configuration, then the HCM tool would all.
What is the secret sauce on how it is pulling in count data? Does it all need to be in CSV format? Can it pull and count data from PDF? And can it pull data from network signals, like from the detection?
I'm glad you asked, because that's something I cut out of this demo, but that's one of the coolest things that we've done. So when you have data, like if you've got data and it's in a PDF, DataPoint cannot ingest that PDF, and ingest the raw file. And so what's the raw file? Well, that depends on the equipment. And so when you want to pull data into DataPoint, you click import here and you just drag and drop the files. But if you don't know what kind of file you need to import, then you click this details button here. And this brings you to a list of all the types of count equipment that DataPoint ingests, and basically all of them. So if it's PextraPro by JMark or Intersections or MyoVision or TracksPro or StarNet or TimeMark or Pico, you find the type of equipment you're using. Let's say it's TracksPro by JMark. That's a common tube count equipment. You click that button and this walks you through what is the raw file. In this case, it's a PRN file. Not the Excel, it's not the CSV. Sometimes it is a CSV, but for this one, it's a PRN file. So you have all your data, you could click export in bulk, export them all as a PRN file, and data would then be able to ingest all those files. You also want to make sure that there's a station ID on the files, because DataPoint, we don't name the stations the cross streets, we give them a number. And so you would put the number here on the file. You would want to make sure you have the date and time, all that standard stuff. You'd want to make sure you assign the cardinal directions. But we walk you through it in case you don't know, and that's it. The important one here for TracksPro would be the PRN file. You're exporting as a PRN file. For the real-time data, the way that works, you send us, so when we onboard a new city or county, the first thing we do is we take 10 years of their historical data, which is all sorts of random Excels and PDFs, because no one keeps raw files. We have a tool and process that can get all that data out of those files and into DataPoint. So we get all your historical data into DataPoint. For your real-time data, you give us access to where that data is going. Go into a server that you have access to. That's an Excel. That's just big data, grows by every row every time a car goes through. You give us access to that. We set up scripts that pull the data, summarize it, and push it to DataPoint all automatically. So then you can upload your short-term duration counts to DataPoint and immediately have it stitched together with the rest of your data. Your real-time data, you just click on that count at that location, and you would see the data maybe from yesterday, maybe done every week, every quarter, however you want it. But it would all be pushed to DataPoint automatically. Does that answer your question?
I think so. Very interesting application and tool. Based on your work on the planning level application, do you think the HCM planning method should be given more prominence in the HCM, maybe equal billing with the ops and analysis method? This one for Bastian.
Yeah, well, a little bit outside of maybe the scope of DataPoint, but yeah, so my personal opinion is that I think the planning methods are extremely powerful, right? And especially, the detailed HCM methods obviously have their benefits, and they give you very detailed performance measures and signal progression and all those kind of things. So the need for those doesn't go away, but I think to me, the power of the planning level applications is, yes, it's for screening applications like this. You can look much more quickly at many more intersections. One of the really nice features that I would like to see moving forward is a 24-hour analysis, right? So we're talking a lot about the AM peak and the PM peak, but if you have a continuous count, 24, 48-hour count, you can see that V over C screening really being a continuous measure. And so I think that, yeah, I would love for it to see more prominence. And again, the methods are already available on there's some sample spreadsheets and those types of things. So happy to talk more to anyone who wants to learn more about the HCM planning level methods. But yeah, just to emphasize, they are an official part of the highway capacity manual. So this is not some adaptation of the HCM. There's really two options when you do an HCM analysis: is either planning or detailed, and this covers the planning.
Yeah, I would also agree very much with Bastian. I've been working with the planning method for a while, and I think one very good application for those who are interested is the ICE process, the intersection control evaluation. I think those of you who are going through this process will find that this is a very appropriate method when you're screening different type of control, whether it's a alternative intersection, two-way stop control, or other. This is the kind of method you want to use in that process. So yes, I would agree that it needs to get more prominence in the highway capacity manual.
Are there any other questions? If you do have some, please type them into the chat. Otherwise, we can break a little bit early. Are there any state DOTs using this tool?
We have, we have Caltrans District 3 and District 11. We're putting together what hopefully will be a pilot program. And then that would be the first DOT. We talked with several others, but that's the one that would be the first one that one.
Give it another few seconds. If you have a question, please type it into the chat and we'll get it answered.
I'll also say regarding state DOTs, for FDOT, there's one of their consultants is connecting us with FDOT to pitch a new crash data tool that we're adding to DataPoint, because we've got all this traffic data, we've got the speed data, and we have the GIS layer speed limits for cities and counties. And so we can automatically, like I mentioned earlier, show you where you have speeding problems. An analysis of just your 85th percentile to the speed limits. We also can show you what the crashes look like around those locations if you have the crash data in a GIS map. So we could show you, fatal crashes and what crashes have bike heads involved. And so we can do crash rates combined with where you have speeding problems. And so that's so maybe FDOT will be interested in that. We're presenting that to them. But if you know of any DOTs that are from a DOT, talk to us. We're doing a lot of unique things with a lot of agencies. And so there's a lot of things that we're not talking about today to keep this on point to the HCM tools. But happy to talk further with any DOTs.
Another question came in. Is this available for consultants?
This is. And so, definitely.
How is the license in terms of cost and fees?
We license basically based upon number of stations. And so for our smaller cities, it's 3-year or 5-year contracts that are $3 or $4K a year. For larger agencies, it's $10K a year, $15K a year. I think San Diego's double that. And so we have a pricing structure that varies based upon the size of the agency. And we calculate that just based upon how many locations you're storing data, basically.
Gotcha. Can you demonstrate the safety crashes component of the application?
Okay, so I'll show you. First, we can toggle on our crashes if you have it in a GIS layer. So I can describe how it would work. We don't have it set up for Alexandria, but for so currently what you can do in DataPoint is, let's find a good intersection. It's got some crashes. Currently what you can do in DataPoint is you can click on a station, see the traffic data. You can click this pencil icon and toggle around some crashes. We can see we've got 20 crashes here. We can download a CSV of these 20 crashes. We can let's pull up our traffic data. Here's our 20 crashes, so we can see they're all angle crashes. We can see all the crash details. All kind of, basic, but still helpful for cities and counties that just can't bite the bullet and pay for the expensive crash programs. You also can, in the corner, toggle on the Google aerial. So you could see quickly, you could see your traffic data, the aerial, and the crashes. Click on these crashes and pull up the crash details. For one city, where potentially adding a feature where you'll be able to edit all of the crash details in DataPoint, because it frequently occurs that the data is incorrect. Police officers put incorrect data in. But the way this will work, or the way that this can work, is we can take this crash data and basically apply it to our midblock data report for the whole system. So you could see where you have speeding problems, and then you could also see the number of fatal crashes, the number of fender-bender crashes, etc., in the same table, and then you can run formulas kind of combining both. So it's frequently, from engineers that we talk to that work in safety, they know where there's crashes, but they don't really know where's their speeding, and because all they have is a bunch of, you'll get a GIS layer with your ADT data, but there's not really a GIS layer with your speed limit data often. And to compare that speed limit, that speed data to the speed limit automatically in a platform can be very helpful. And so then DataPoint does that, but then also will show you those other crash metrics you want to see. I can't really show you any more than that for this demo.
How are they located in the software? I assume by that they mean crashes.
So every state does crashes differently. There's some cities where they will have us build out these crash layers, and we can do that for agencies if they don't have that data geolocated, meaning they've got all these crash reports, but they don't have the latitude, longitude. We can build that out. We have a tool to build that out for them. But for Alexandria, they get this crash data from the state annually. And so, yeah, it depends. But if the state's got the data, we can either help them get it in a GIS, or they'll normally have it internally, or we'll get it from the state or MPO or county.
Awesome. We're at time, so we're going to go ahead and close this out. But if you have any questions, please feel free to follow up. You can reach really any of us. I guess, Stephen, what's a good email to get in touch?
Well, if you want to get in touch with Bastian or Nagui, they could put their emails in the chat, and I'll put my email in the chat. And yeah, that may be the easiest way. For mine, it's shollenkamp@qualitycounts.net.
Awesome. Thanks everybody for attending. Hope you had a good time. We will send out a recording of the webinar no later than Monday of next week. So be on the lookout for that. Otherwise, have a great rest of your day, and hope to see you at the next one. Bye, everyone.
Thanks, everyone.